So, hello students and welcome again to my channel FiSci. Uh, this is lecture number 3 on differential equations, and here we have problem number 3. Okay, we just have to solve this differential equation. Okay, but this time uh, we would use the Laplace transform to solve this equation. Okay, now this equation can be solved by another method. Okay, and we have already done the problem number 1 by that method. Okay, now for this particular equation, it is a, you can see, a second order differential equation. So how can we apply the Laplace transform? First of all, we'll look, we'll try to find out how Laplace transform can be used, and then I will apply the Laplace transform to solve this equation. Okay, so it is not that difficult, but you should have some knowledge of Laplace transforms. Okay, so uh, we know the Laplace transform of some function. It is given by this integral. Okay, okay, now let us take the uh, Laplace transform of the first derivative of some variable y. Okay, so I can write it as infinity, and then y dash, which is also a function of t, and e raised to power minus pt and dt. Now I will apply the integration, integration by parts. So it will be equal to e raised to power pt, and then differentiation of this y dash, and it will become y, and then limit 0 to infinity, and this is minus, and then integration again, and differentiation of this, and it will come out as minus p, and we have integration and differentiation, integration of y dash, it becomes y, and then e raised to power minus pt and dt. Okay, 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 okay. Now it will become when we apply this limit infinity to this, it becomes 0, and when we put 0 here, and we'll get just y at 0. Okay, I can write it as y at t is equal to 0. Okay, plus this is p, and what is this? This is actually the Laplace transform of y, so I can write it as this. So if we have just the first order differential equation, we can put uh, this for the Laplace, for Laplace transform of y dash. Okay, so let's say it is equation number 1. Now we have to find the Laplace transform of ly dash, y double dash. Okay, first of all, let me write this as a simple form: p capital Y, where y is equal to Laplace transform of y, capital Y, and then this y naught. Y naught means the value of y at x is equal to 0. Okay, now L y double dash. So what can I write? Okay, it becomes ly dash. Okay, just put y dash in place of y, and it becomes y0 dash. Okay, what I've done, I've just put y dash in place of y, okay, in the above equation. Okay, let's say it is equation number 2. Okay, now we have two equations. This is equation number 1 and this is equation number 1 and 2. Okay, now we want to eliminate the ly dash from these equations. Okay, so we put ly dash from this equation here, and it becomes minus y naught plus p ly, and then minus y dash 0. Okay, so this can be simplified as ly double dash is equal to, this is p square, and ly can be written as capital Y, minus this is p y naught minus y dash naught. Okay, now we have both the equations. We have Laplace transform of y dash and we have Laplace transform of y double dash. Okay, let's say it is equation number 3. We'll use these two equations to find the to solve the differential equation. Now about the problem. Okay, here we have y double dash plus 4y dash plus 4y is equal to t square e raised to power minus 2t. Okay, this is our problem that we have to solve today. Okay, let's take let's take Laplace transform of each term. Okay, so how can I write it? I can write it as ly double dash plus 4 ly dash plus 4 of ly, and it is equal to Laplace transform of t square e raised to a minus 2t. Okay, it is simple. Now we have to put the value of ly double dash and ly dash from equation 1 and 3. Okay, so we'll get what? It will equal to p square y minus py naught and minus y naught dash. This is for Laplace transform of y double dash. Okay, and then plus 4 py minus 4y naught. This is for Laplace transform of y dash, and then plus 4y, and then Laplace transform of t square e raised to power minus 2t. Okay, now sorry, I haven't given the initial condition. Initial conditions are such that y naught is equal to 0 and y dash naught is also equal to 0. It means at x is equal to 0, y is equal to 0, and at x is equal to 0, y dash is also equal to 0. So this and this will become 0, and what will get? I'll get p square plus 4p and plus 4 of y. Okay, this and this, okay, is equal to Laplace transform of t square e to power minus 2t. Okay, now I have to find the Laplace transform of this side. Okay, so I am using a direct formula, which is Laplace transform of this function is equal to k factorial p plus a k plus 1. This is the Laplace transform. Here we have k is equal to 2 and a is equal to 2. A is also equal to 2. So we have L of t square e raised to power minus 2t is equal to mm, 2. Okay, 2 factorial 2, and then p plus 2 raised to power 3. Okay, let me put it. Okay, we'll have and what this, this is p square plus 4p plus 4, it is equal to p plus 2 whole square. Yes, so I can write p plus 2 whole square y is equal to 2p p plus 2 cube. Okay, now y is equal to 2 divided by p plus 2 raised to power 5. And what is y? Y is equal to Laplace transform of y is equal to 2 upon p plus 2 raised to power 5. Now y is equal to, so y, I, if we have to find, if we have to solve the differential equation, we have to solve this differential equation, we have to find the expression for y. Okay, so y is equal to inverse Laplace transform of this equation. So how can I use it? I can use the same formula. Okay, from this formula I had tk e raised to power minus 80. The Laplace transform of this is equal to k factorial p plus a k plus 1. Okay, okay. So I can write that inverse Laplace transform of k factorial p plus a raised to power k plus 1 is equal to tk e raised to power minus 80. Okay, so here k is for this I can write y is equal to we have okay. Okay, for this we have, this is k plus 5. Okay, so I can write it as I can take 2 here, so it becomes y by 2, and this is k factorial, so I can write it as p plus 2, a is 2, so p plus 2, and this is can be written as 4 plus 1. Okay, L inverse. Okay, now we have the final formula. Okay, so here I have 1. Okay, so I can write here 4 factorial and 4 factorial here also, so I will get y is equal to, now I have the formula, this is 4 factorial p plus a 4 plus 1. Okay, so inverse Laplace transform of this will be equal to I will take 2 and 4 this side. Okay, so 2 and 4 factorial, and in the bracket I'll have t raised to power k, so t raised to power 4, and then e raised to power a is 2, so minus 2t. Okay, 4 factorial is 4 square 12 24. Okay, it becomes y is equal to t raised to power 4 e raised to power minus 2t and divide by 12. So here we have the solution. This is the solution of this differential equation. You can see that this method is very powerful. Why? Because in first look, you can find it difficult, but it is actually an easy method, but you have an initial knowledge of Laplace transforms. Okay, the this method is also also very good because in this we don't have to put the initial condition at the end of when you are solving, and you have to find those constants okay, by putting the initial conditions. Okay, so it is a very good method to solve these types of differential equation. Okay, so I hope you understood all of this. If you have any query or any doubt, you can ask me in the comment section, and if I have wrongly written something, so please let me know and pardon me. So okay, okay, tata, bye bye, meet you in the next lecture. Okay, okay, bye.